What about this one? Does it matter that before we had CO2 and now we have aluminum?
No.
Does not, right? Because remember, it doesn't matter. 1 mole of anything is 6.02 times 10 to the 23rd of it. So calculate this one for me. And you're going to struggle later. All that's happening, these are just like grams and centimeters and stuff, right? All we've done is change the words here. Same problem though, okay? So the answer is, we're all good? Still using the same fact. Except now you have what? Now you have atoms, and you want to go to moles. Write it out. All right, I'm gonna write it out on the board, and I want everybody to do the math real quick, okay? So we start with atoms, right? 1.8 times 10 to the 24th atoms of sulfur. Doesn't even matter that it's sulfur, does it?
No.
Because what do we know? 6.02 times 10 to the 23rd atoms of sulfur is 1 mole of sulfur. So if you don't write these units on here, some people, like I know in the last class, they were saying, well, I just need to know that I got to divide. I'm like, you want to memorize every problem and know that you got to divide or multiply for every certain situation? Good luck to you. I would much rather be able to recognize it. Look, here I have atoms of sulfur, that's where I started. And this is the definition of a mole, isn't it? And atoms of sulfur cancels. Now, did everybody do it in your calculator?
Yes.
Everybody did it on your calculator. All right, I want everybody to vote. Ready, set, vote. Hold on, she's still thinking. I want you to vote. You gotta vote for one. You don't have a choice, you gotta vote. You vote, you said one? You did it on your calculator, you got the answer is 1.
I think so.
Do it on your calculator. Do it on your calculator and tell me what you got. I don't know how you get 1. I know how you get this answer here. I don't know how you get that answer there.
I can get this in.
The memory. Is everybody using the scientific notation button on you? Okay.
Yes.
Everybody using the scientific notation button on your calculator? Double E?
Yes.
Because if you don't use double E, somewhere you're going to get order of operation errors and you get this one. And that's wrong.
I did use that one. So I can even get it.
The answer is 3, right? This is the answer. Well, here we have a molecule of aspirin. How many atoms of carbon are there? What? How many atoms of carbon? 9. How many atoms of hydrogen?
8.
And how many atoms of oxygen?
4.
Who's ever seen 1 molecule of aspirin? Nobody? Why not? Because it's too small to see, isn't it? So what are you going to think we're going to do with molecules? We're going to scale them up doing the same thing, right? So if you have a mole of aspirin, you also have 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. Right? True? Because you would have, if you had 1 molecule, you would have 9, 8, and 4. So if you have 1 mole, you have 9, 8, and 4. So in 1 mole of aspirin, it contains 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. Well, if that's true, then we can write all of these conversions from that. Yeehaw! 1 mole of aspirin contains, these first 2 are for carbon, right? 9 moles of carbon for every 1 mole of aspirin. Doesn't matter which way we write it, you can flip it upside down. Same thing for hydrogen and oxygen. So there are 6 possible conversions that we could do using this. How do we choose which one we're going to use? Depends upon what we're given and where we're trying to go to. Okay? It's not that simple, right? You got to know something about the problem. And you got to make an informed decision. So, let's look at a problem. How many atoms of oxygen are in 0.150 moles of aspirin? Now I'm going to tell you, I want you guys to try to work on this. This is not an easy problem for most of you right now. This is a two-step conversion. Okay? Think about what we can do. We can go from moles of aspirin to moles of oxygen, and then we can go from moles of oxygen to atoms of oxygen. That's how I want you to try to do it. Okay? Two steps. Are we ready? Couple people? You want to try to do it together, and then we'll do another one in a minute, separate? Okay. What do we have? We have moles of aspirin, right? So that's where we have to start. I'm going to read it like that. Well, what can I change moles of aspirin into? I could change it into molecules of aspirin, or I could change it into moles of oxygen, couldn't I? Because it tells me in the formula that 1 mole of aspirin is what? 4 moles of oxygen. Because of the subscript right here. Okay? So now, moles of aspirin cancels, and I have moles of oxygen. What have we been doing? We've been converting moles into what? Atoms, haven't we? Because we know that 1 mole, in this case oxygen, is 6.02 times 10 to the 23rd atoms of oxygen. Do it? Why are there 3 sig figs in the final answer? Because there's 3 sig figs when we started. At least you noticed now, right? Before you never would have even thought about it. Okay. Oh, you wanted to do one more like that, huh? Let's do one really quick. .315 moles of C6H12O6. And we want to go to carbon. We don't want to be in this, right? We want to get out of whatever molecule this is. Well, 1 mole of C6H12O6 has how many moles of carbon in it?
6.
6 moles of carbon. Then 1 mole of carbon has how many atoms? 6.02 times 10 to the 23rd atom. Now, I don't know what the answer is.
1.14 times 10 to the 24th.
1.14 times 10 to the 24th. Okay. You're a fan. All right. Now, we've been talking about atoms and molecules and even formula units. But those aren't useful things. We said an atom was too small, and we want to scale up to something usable. Who has their periodic table with them? If you look at this on the periodic table, you're going to need a periodic table in it. You remember when we talked about the periodic table? What does this number 11 tell me up here? It's the elements identification. It's called the atomic number. And what does it tell me about this atom? Has 11 protons. What's this number on the bottom down here? This is not just the molar mass, this is the atomic mass on the periodic table, okay? On the periodic table, this is the, remember when we talked about isotopes? This is the weighted average of all the isotopes. We didn't do that calculation. I said it wasn't worth us doing. I don't want to tell you. But this is the number that we're going to use. It averages all the isotopes, basically, okay? Now this number originally is what one atom of sodium, what the average atom of sodium, what its mass would be. The units are atomic mass units, okay? But atomic mass units aren't very useful. But if we scale from 1 atom up to 1 mole, we can change this unit from being atomic mass units up to being grams. 1 mole of sodium would have a mass of 22.99 grams. What do you think the mass of 1 mole of aluminum is? Anybody?
26.98.
26.98. And where'd you see that? On a periodic table, right?
Yes.
Okay. That's not too tough, huh?
No.
Okay. Now, what are the units on that? The units are, it's called molar mass, and I don't like how they write this. I would write it as 22.99 grams in 1 mole. The units are grams per mole. So what do you think we're going to do with this eventually? It's got 2 units. What we're going to use it for?
Conversion.
We're going to use it to do a conversion, aren't we? We're all about doing some conversions. Because we love them, don't we? Liar. Okay. So it's called, this unit is called the molar mass. It is the mass of 1 mole of any element. It's found on the periodic table. Carbon, it would be 12.01 grams. Lithium, 6.941 grams per 1 mole of lithium. Note that carbon has a mass that's about twice that of lithium. Why? Because it has more protons than neutrons, doesn't it? So its mass for 1 mole is bigger than it is for lithium. Just because it has more protons than neutrons. So, yeah. To calculate the molar mass for a compound or a formula unit, what do we have to do? We have to add all the masses of all the atoms in there together. Let's do an easy one first. Let's do water. What's the molar mass for water? Molar mass for water. How many oxygen? I have oxygen and hydrogen, right? How many oxygen atoms do I have?
1.
And how many hydrogen atoms do I have? 2. If I look at the periodic table, the molar mass for oxygen is what? 16.00?
Yeah.
For hydrogen, 1.01. Then I add them together. Oop. 18.02. The units would be grams per mole. Okay? Does everybody see how I did that? There's 2 hydrogens and 1 oxygen. Multiply them by the mass on the periodic table, then add them all together. We're going to do a couple more, I promise. Okay?
And the unit at the end is grams per mole?
The unit at the end would be, if you were asked for the molar mass, would be grams per mole. That's how much 1 mole, what the mass of 1 mole would be.